So hello students, welcome back once again, and I hope everybody is doing fine, and we are reaching towards the end of the chapter, but stop there. It is not the end yet. Okay, so is matter around us pure is what we are, studying so far. So today we are going to deal with a very interesting topic, which is very close to my heart as well. That is physical versus chemical changes. Okay. So now I would like to pose a question, and if you want to answer, maybe you can comment or something that, or maybe you can just think about it, whether you like a change or not. Okay, this can be a very philosophical question and maybe away from the topic, but I just want to know whether do you like a change or not. If you're moving to a place, okay, if you are going from your grandparents house to back to school, maybe, or maybe you are going for holidays, some vacation somewhere else, or if you are changing your house, if you are changing and buying a new car, your parents, or moving cities, so do you like the change or not? That is what, like, I want to know. Okay, so with that thought in mind, you can keep thinking, and we can move ahead to the session. So there are two types of changes. Personally, I sometimes like change, sometimes I do not. Okay, so the change in science is a little bit more different than the philosophical question I asked earlier. Okay, here there are two types of changes, physical and chemical changes. Now there are matter around us and it goes through changes. Okay, so what exactly a change if we are looking through the lens of science again? So a change here would be an alteration, or a substance, when a substance gets altered, okay, and there is a change in the state, its state. Can you tell what three states are there? Solid, liquid, gas, right? So if there is a change in the state, if there is a change in the shape, okay, if there is a change in the size, something is small, something is big, okay, or composition, okay, maybe you used to like chocolates, maybe ice cream made up of chocolate, now you have changed to vanilla, okay, so that everything, these all small little changes, okay, maybe somebody's cutting a tree, maybe you are cooking food, you are helping your dad cook food, okay, or maybe I am like keeping this water, okay, in freezer. So this all comes under change in science. Now we can categorize them into two types of changes, that is physical and chemical. Okay, the physical change would be usually a change, I'm saying usually, okay, a change where no new substances form. That means the water which I kept in the freezer, okay, when I took it out, it became ice, but the composition, this composition we were talking about, right, it remains same. What is it? H2O. It is made up of H2O. So this is going to still be a water, right? So no new substances formed here. But a chemical change, for example, let's say, first of all, let's say here what happens is one or more new substances form. Okay. So here, if you are burning a paper, you will see that the ashes will be formed. Okay. This ashes is new substance. Now, here you can turn ice into water and water into ice. Again, it is a reversible process, right? So most of the changes, physical changes, are reversible in nature. You can reverse it. You can make water with ice, ice with water, right? You can do that. But here, once you have burnt the paper, you'll see that ashes are there. There is smoke coming out from it. Now, can you take the ashes and the smoke and turn it into a paper again? No, right? Here, two new substances are being formed, or more substances are being formed. So the substance has completely, and its properties is also being changed, because again, it has turned into something new. So its properties will also change. Okay. Now, let's see what exactly a physical change is. Okay, so physical change is a transformation where only physical properties of a substance will be changed. For example, let's say I'm taking a pen and a paper. I hope it's visible to you, maybe. Okay, so if I'm taking this paper, okay, even if you are unable to see, just imagine if I'm tearing it, or okay, or if I'm crumbling it like this, okay, then I'm able to make it again back to a normal paper, right? If I tear it, maybe I'm unable to, maybe I can use a tape or something or join it, but then again, it'll still be a paper, right? Even if I tear it into pieces, it will still be a paper. So no new substance is being formed. If I color it, add color on the top of it, still it will be a paper, right? So a physical change is a transformation where only the physical property, okay, so these properties, the change in the shape, size, color, that is the physical property of a substance. So only physical property is being changed without forming a new substance, okay? Think of it as a substance simply changing its disguise, okay? Maybe changing the outer covering, but still stays the same. So examples, melting of ice. So ice, again, this ice will it gets converted into water, right? And water remains water only. Okay. Boiling water, even if it gets converted into water vapor, again, you can turn it into water, right? It will rain and it will become water. Breaking of glass. Now you'll think, ma'am, the glass is broken. We cannot, make it. It is not reversible to add, up all the pieces and make the whole vase again as the same vase which it is used to be, right? So it will stay in pieces, but still those pieces are glass only. So that is a physical change. Dissolving sugar in water. Sugar is still sugar. It just got mixed with water. Okay, it just got disappeared, but it is sugar. It does not change into alcohol or maybe, carbon dioxide or oxygen. It stayed sugar only. So this is all physical change happening on a physical level. Okay, no new substance is formed. It is often reversible. I told you, often we are using, remember this term, it is often, or you can say usually, because sometimes it cannot be reversible, like breaking of something, right? If you break something, you can't join it as it was before. Okay. Energy change during the process is usually small. Very small amount of energy is used to convert something or, in the physical change process, right? I hope this is clear. Now coming to the chemical changes. Now you will be able to compare these two. Okay. So chemical change is just the opposite of physical change. Here what is happening? A chemical change is a process whereas new substances form. So remember the example of the ashes being formed from the paper, right? So that is what happens here. Now burning of a paper. A paper turns into ash and smoke. Okay. Now it's not going back to becoming a paper again. So this is a chemical change. Rusting of iron or iron. Okay. Iron reacts with oxygen to form iron oxide. Okay. So this is also a chemical change because iron became something new now. Oxygen has been attached to it and became something new only. Okay. Now coming to cooking food, raw ingredients transform into a new dish. Okay. So cooking food, if you're cooking food, you have cooked it. Now you cannot uncook it, right? Once you are doing, okay, you are making the dough. Okay. So that is okay, right? You are doing some physical activity and changing shape and everything, right? After you have taken the dough and made chapati out of it, okay, then you cannot go back to make it being a dough again. Okay, so that is a chemical change. Wherever, okay, just to give you a hint, wherever the temperature or you can say the heat is involved, that is mostly going to be a chemical change. You can recall it like that. Curdling of milk. Milk proteins change structure. So once curd is made, you can't go back and make it into milk. That is not possible again, right? Not reversible. So it is a chemical change. So new substances being formed in a chemical change, it is usually or often irreversible. That means it is difficult to get it into its original state. Okay. Energy change is often significant. Okay, that means heat, light, sound might be produced. For example, you are bursting a cracker. Okay, so what happens? Heat will be released, a lot of heat. You will see light also and pop sound, right? A sound. Even in chemical changes also, you will notice when you are doing some experiments, right? Sometimes you will see light. Okay, sometimes you'll see heat or maybe sound, or even color change also is seen in chemical reactions also. But the difference is the color change and physical changes would be on a very surface level, like you have painted something or you have colored something. But in chemical changes, the color changes from within. For example, ripening of fruit. Ripening of fruit is because of, 1 second, fruit. Let me just write it R here properly. Fruit, ripening of fruit. Okay, so if a mango is, ripen, so why is it so? Because hormones are being released and they are causing chemical changes inside the, mango, and that's why it changed color from, red to being orangish yellow or yellow, basically. Okay, so that is a chemical change. Okay, so here you can see the difference again now. So if we look at the difference, so if we see the properties or the aspect, new substance, is it being formed in a physical change or not? No, it is not being formed. In a chemical change, does a new substance is formed? Yes, it does. Now, properties. So chemical change, physical change has same properties as before, because it was paper, right? And if I tear it or color it, again, it is going to be paper only. Okay, but here the chemical the chemical change is there, so properties will also change. And to be precise, chemical properties will change. That we'll see later. Okay, in higher grades, you will see what exactly do I mean by that. Now, reversibility. Often it is reversible. You can reverse it, like you remember, right? Now here, usually it is irreversible. So once a paper is, burnt, it cannot be reversed. But here, you remember that if I'm folding a paper, again, I can go back to, making it a normal paper again. Now, energy change. Here, the energy is very small energy is being used. Here, large amount of energy is used. Okay. Examples would be melting, dissolving, boiling. And here, burning, rusting, and cooking. Okay. So if you melt something, if you dissolve something and boil something, that is nothing but a physical change. But if you're burning, if rusting has occurred, that means oxygen has been added to that substance. And cooking, there is a chemical change. This we have studied in class 7th also. So I hope this topic was much easier, right, than other, new topics. Okay, the energy involved, the fuel behind the changes. So energy plays a very, very important role or key role here. Okay, the amount and type of energy exchange can help us distinguish between these two. So if the energy is very, very small, okay, so there has been a physical change. But if the energy is in large quantity or large amount, so there has been a chemical change. In physical change, energy is typically absorbed or released to alter the state or arrangement of particle, but do not break break the particles bond between them. So here what is happening, for example, let's say water particles again we are, and in between that we have added salt. Okay, we are mixing it. So what is happening? Basically, the salt is being, the arrangement of particle is becoming such that the salt is getting dissolved in between the intermolecular spaces of water. Okay, of water. So the arrangement of particle is being changed here with the help of little bit of energy. But here what happens? These bond will be broken. The bond between, water will be broken and it will become something else. Okay, maybe oxygen. If you will study about the respiration and, photosynthesis reaction in higher standards, then there you can understand, breaking of the bonds and all that. Okay. Now here, you can see chemical changes involves breaking of the bonds and the formation of new ones. New bonds will be formed, which requires and releases substantial amounts of energy. So a lot of amount of energy. So on that basis, we can divide or, distinguish between physical change and chemical change. Example would be burning fuel releases significant heat and light energy as carbon and hydrogen atoms rearrange to form carbon dioxide and water. Okay, so you're using the fuel, petrol, right? And diesel maybe, or some other, CNG and all you are using. So those bonds of those, particles are breaking off and then making new bonds and forming new substances from it. Okay, which comes off as a, waste, you can say. Okay. Okay, so how do we know that something is actually a chemical? So chemical changes often leave behind clues. Okay, so what would it be? I told you, if ripening of a fruit, if the color is coming from within, you are not applying it, or it's not from external. Okay, so that is a chemical change. So like for example, iron changes into reddish brown if it rusts. Okay, then gas formation. So gas, sometimes gas is also formed. Okay, when you will see that antacid dissolves in water, if you'll see that experiment, maybe. So what happens, a gas like bubbles will be formed, and that bubbles are example of or you can say that they are projecting that gas is formed. Okay, right? Now coming to temperature change. So you will see that either the temperature drops or the temperature rises. So there will be either heat release, okay, or heat absorption. So all these are basically giving a sign to you that it can be a chemical change. So with these signs, you can understand. Precipitate formation, a solid formed within a liquid. This also we'll deal, in depth in our classes. And then light or sound produced, as vividly demonstrated by fireworks. So fireworks are the best example of a chemical change. You'll see light, you will see heat, you will see sound there. Okay. So now the physical change and chemical change, you can like see the melting of the butter or boiling of water or chopping of vegetable will come under a physical change. This is, day-to-day life examples. And if you will see chemical change, so burning of wood, if, chopping a wood would be coming under physical change, but if you're burning it, then it comes under chemical change because new substances being formed. Rusting it, again, new substances being formed. So that is a chemical change. Cooking vegetables. Now, once you are cutting it, physical change. Once you are cooking it, then it is a chemical change. Just try answering this. A candle. Okay, candle is burning. What kind of change or what kinds of changes you can notice when a candle burns? Try solving that. I can give you a hint that physical and chemical, both sort of changes are there. Now you have to tell me exactly which part of a candle is showing physical change and where is a chemical change seen. Now you can try answering these questions. Question 1 would be, ice melting is a physical or chemical change. I'm sure you all are going to say A. I hope that's the answer. Okay. Which of these is irreversible? Boiling water, rusting of iron. Again, try answering that. Or if you have doubt, just ask me. Formation of bubbles during a reaction after indicates physical change or a chemical change. Again, we have just now studied that, right? Gas formation. So thank you so much for joining the session. I hope you enjoyed the session. And if you have any doubts, you can quickly reach out to me. Feel free to ask me any doubts or any questions regarding these topics or maybe something else which you want to learn from me. Okay. So thank you and bye-bye. Take care. And try also, finding two chemical and physical changes as well. Okay. Bye-bye.